So what's going on YouTube? Recently I had trouble explaining Kerberoasting to a friend. That got me thinking, if I found it challenging to explain, others might also struggle to understand both the concept and technical details of this attack. This video will help you understand it better in just a few minutes. Let's get started. Before we dive into the attack, let's quickly review how Kerberos works in Active Directory environments. Kerberos uses tickets for authentication with several key concepts. In Active Directory environments, these components, KDC, AES, and TGS, are all part of the domain controller. The DC handles all Kerberos authentication requests, acting as a centralized authentication service for the domain. The most confusing part is understanding what an SPN actually is. An SPN, Service Principal Name, is a unique identifier that Kerberos uses to associate a service instance with a service logon account. I know this explanation of SPNs can be found in many places, but it often takes time to fully understand the concept. Let's examine the actual SPNs in our CTF environment. For this demonstration, I will use the active machine from Hack the Box. Here's the ldapsearch command we'll use to identify misconfigured SPNs. When examining the LDAP output for the targets, the administrator account with SIFS SPN stands out as a prime target for several key reasons. Oh, by the way, this is a misconfiguration. Admin shouldn't be there. The administrator account is a prime target for attackers because it's the most powerful account in the domain. What makes this attack so dangerous is that any regular domain user can grab a TGS ticket encrypted with the admin's password hash and try to clock it offline without raising any alarms. The DC account represents a domain controller computer account. While it has many SPNs, we'll skip it because its password is automatically managed, extremely long, and frequently rotated, making cracking attempts impractical. Let's try GetUserSPNs to see if our understanding is correct. The tool's advert says that admin is mistakenly tied to SIFS SPN. This confirms we are on the right track. Can we get the same results as ldapsearch using this script? Yes. Comment out the two lines like this. This time, we can see a lot of SPNs and DC's hash here. While we can see the hash, it's not a practical target for our attack. This is because the domain controller's password is automatically managed by the operating system, making it extremely difficult to crack. This comparison helps us understand not just what tools to use, but also which targets are worth pursuing in a real-world scenario. What we should do next is very simple. Request the TGS and crack the hash. Since I couldn't find an actual example of a TGS ticket, I decided to modify the GetSPN user's code to extract one. You can check out the authentication process. This is legitimate and nothing exploitable other than the misconfigured service account. First, we get TGT. In other words, domain logon. Then we get the TGS as SDC TGS. The TGS process is tied to the SPN, where the admin account is mistakenly bound to it. The TGS is encrypted by that account's password hash and timestamps. Sometimes, when requesting TGS tickets, you might encounter a clock skew to grid error. This happens when there is a time synchronization issue between your machine and the domain controller. To fix this, you can synchronize your system time with the domain controller like this. Here's the raw TGS ticket. Most documentation only shows the final hash format or simplified diagrams. Having access to a complete TGS ticket structure helps us better understand how Kerberoasting actually works at a protocol level. Let's break down the TGS ticket structure in detail. I might have gotten some details wrong here since this stuff is pretty complex. Let me know if you spot any mistakes. This section contains standard client identification information. I mean, there's nothing noteworthy here at this moment. This encrypted section is what we target with Hashcat. The E-type 23 indicates LC4 encryption, which means we can crack this hash quickly with a good dictionary and sufficient computing power. Note that this portion changes with each request since it's generated using the current timestamp and service account hash. This temporary session key enables secure communication during this specific Kerberos exchange. We'll skip analyzing this part for now. The resulting hash can be cracked using Hashcat. One thing I can share is that Hashcat can detect the hash type automatically, so the -M option can be removed depending on their version. Understanding Kerberoasting at this level helps both attackers and defenders. For red teamers, it provides a reliable privilege escalation technique. For blue teams, it highlights the importance of service account security and monitoring TGS requests.